Hello and welcome to Vodcast 11.2. In this podcast, I will provide a general overview of the 4 layers of Earth's atmosphere. Let's start with the layer of our atmosphere that we're most familiar with, the troposphere. This is the layer of our atmosphere in which we reside, and this is also the layer of Earth's atmosphere where all weather occurs. 2 very important notes to make on this slide are, as previously mentioned, the troposphere is the lowest layer in our atmosphere, and that as you work your way up through the troposphere to higher altitudes, the temperature will decrease. Now, if you're wondering about the rate in which the temperature decreases with altitude, we can take a look at this environmental lapse rate as shown on the screen. For every 1,000 feet that you go higher into the atmosphere, the temperature will drop approximately 3.5 degrees Fahrenheit. Now, the thickness of the troposphere can vary, but on average it's roughly 12 kilometers high, or 7.5 miles high. And then once we reach the very top of the troposphere at roughly 12 kilometers, we've reached the outer boundary of this layer, and we call that the tropopause. If you go higher than the tropopause, you enter the next layer of Earth's atmosphere, which is the stratosphere. I'd like to briefly call your attention to the graph shown on this slide. If we start at ground level and work our way to higher and higher altitudes, we should notice that the temperature is dropping quite rapidly as we have an increase in altitude. At the very top of the troposphere, where the tropopause occurs, the temperatures drop to almost 60 degrees below zero on the Celsius scale, or about 75 degrees below zero on the Fahrenheit scale. So once more, the key points to know about the troposphere are that it's the lowermost layer in our atmosphere, and the temperature will decrease with increasing altitude. Let's talk about the other 3 layers of Earth's atmosphere. On the previous slide, I mentioned the stratosphere, and that's the layer directly above the troposphere. The stratosphere occurs between altitudes of 12 kilometers and 50 kilometers. And at the very top of the stratosphere, at that 50 kilometer altitude, we see the stratopause. And that stratopause serves as the boundary between the stratosphere and the mesosphere. It's important to note that in the stratosphere, the temperature will increase with increasing altitude. Now that probably sounds weird to you, but let me explain why that occurs. Our planet is very fortunate to have an ozone layer. Ozone is extremely important because it screens out some of the very harmful ultraviolet radiation coming from our sun. Now, the ozone layer occurs in the stratosphere, and when those ozone molecules absorb that ultraviolet energy, the stratosphere will be heated. So if we take a look at where the stratopause is, which is the top boundary to the stratosphere, the layer that sits above the stratopause is the mesosphere. In the mesosphere, the temperature will decrease with increasing altitude, just as it did in the troposphere. And notice that some of the lowest temperatures that can occur in our atmosphere occur in the mesosphere. Our understanding of the mesosphere is kind of limited because it's not a very accessible part of our atmosphere. Our best research balloons can't really get to that altitude, and the mesosphere is too low for our lowest orbiting satellites. So in terms of our atmospheric layers, it's kind of out in no man's land. However, recent technological developments should help us understand this layer much better in the future. Our last consideration in this vodcast is the thermosphere, and the thermosphere is the uppermost layer of Earth's atmosphere. There's really no well-defined upper limit for the thermosphere, which is why you don't see a thermopause. It's kind of a gray area when transitioning from the thermosphere to outer space. It's also important to note that the thermosphere is a very small fraction of our atmosphere's mass. If you take a look at this graph, you'll notice that the temperature increases with increasing altitude in the thermosphere. But that's kind of misleading. To explain this, we have to understand conceptually what temperature means. In its simplest terms, temperature is a measurement of the kinetic energy of particles. You can almost think of it this way. In hot water, the water molecules are jiggling really fast. But as that water cools, they'll start to jiggle slower and slower. Now the temperature will increase as you go higher and higher into the thermosphere because the thermosphere serves as our first defense from incoming solar radiation. The atoms in the uppermost part of our thermosphere will absorb solar energy, and that will increase their kinetic energy. But it's important to note that in the thermosphere, the gases are so spread out that they collectively possess an insignificant amount of heat. In other words, the 40 degrees Fahrenheit you would experience in the troposphere is not going to be the same as the 40 degrees Fahrenheit that you would experience in the thermosphere. Okay, that concludes this video podcast. I hope it helped you develop an understanding of the layered structure of our atmosphere. And in our next video podcast, we'll turn our attention to rotation, revolution, and Earth's seasons.